Okay, that's the aim. We're going to be doing geometric series and infinite series. Once again, we're just doing the mechanics, and then in the next class, we're going to start to get more application. So, geometric series, it's the sum. So, it's the sum of the terms of a geometric sequence. Once again, geometric sequence, the recursive formula is that we need a common ratio to get to the next term, like times 2, times 2, times 2, or times a third, or negative a half, or something. So, for example, if I want to do 1 plus 2 plus 4 plus 8 plus 16, you recognize this as a geometric sequence. The first term is 1. The common ratio is 2. We know how to figure out the common ratio. We know the formula from the formula booklet is the sum of the first n terms, f of n, is u of 1 times 1 minus r to the n over 1 minus r. Now, the first formula is always 1 minus r to the n because that's how they derive it. But you could also just flip these around. Or u of 1 times r to the n minus 1 over r minus 1. It's your call, whatever you want to do. Let's just go through the variables. U of 1 is the first term. R is the common ratio. We know that n is the number of terms. And S of n is the sum of the first n terms. And so we simply plug it in the formula. So it's S, so we know that it's S of 5 is equal to 1 times, I'm going to use the second formula because I know it's 1 minus 2 to the something, and I don't like negative numbers. So 2 to the 5th minus 1 over 2 minus 1, and that's 32 minus 1 is 31 over 1 is 31. And that makes sense. 1 plus 2 is 3, plus 4 is 7, plus 8 is 15, plus 16 is 31. A more advanced problem, let's do an application problem. Let's imagine that the first year that you're working at a company, let's say over the years, like you start, your first salary is, your first year of pay is $10,000. And then each year you get a 7% raise. So the second year, each year is a 7% raise. So the second year, you get 1,000 times 1.07. And then in the third year, you get 10,000 times 1.07 squared, right? That's it. So the question is, if you didn't spend a cent, so you don't spend any money, and it goes right into the back, and all the money goes into the bank, how much would you have after 8 years? How much money would you have after 8 years? So you realize that because each year you keep multiplying by 1.07, it's a geometric sequence. The first year is $10,000, and you know the common ratio is 1.07. And so after 8, and n equals 8. So What is S of 8? Take a second to figure that out. Okay, we're back. So we know it's 10,000 times, maybe I'm going to use either formula is fine. I'll use the first formula because that's what I see in the formula booklet. Divided by 1.1 minus 1.07. The final answer is $102,598. Please make sure that your calculator can do this. The second you start seeing 1.07, you're like, calculator. Okay. So what I'd like you to do is everyone got this? I'm erasing. Okay. What I want you to do is, if I had you in the class, what I'd have everyone do is, I'd have you add, 1 plus a half. And then you'd add a fourth. And then you'd add an eighth. And then you'd add a 16th. And then you'd add 1 over 32. And the question is, can I go to an infinite number of terms? Can I keep doing these out to infinity? And so you might say, well, no, if you add an infinity number of terms, that might go to infinity. That number is just going to get ridiculously large. But then you look at this example, and you start to notice that the numbers start to converge to 2. This sum seems to converge to 2. The idea, and that's the idea. So we're going to talk about, can I add an infinity number of terms? Well, let's look at our sequences. In this class, we've only looked at arithmetics and geometrics. So let's start with the arithmetics. Right? 1 plus 2 plus 3 plus 4 plus 5. Well, no, that's diverging to infinity. So we can't do anything with the arithmetics. If I went to negative, you might say, well, what about negative numbers, Mr. Adler? Negative 5, minus 10, 15, 20. No, that's also diverging to negative infinity. So the arithmetics, you can't do anything. What about the geometrics? Well, the first geometrics we looked at was, 1 plus 2 plus 4 plus 8 plus 16. But, no, that's also diverging to infinity. So, but we know that some of these worked, actually. Well, it turns out that the sum of an infinite, you can add up the infinite terms of, so you can add the infinite, you can add the terms of an infinite geometric sequence if, actually it's if and only if, but we don't know what if and only, don't worry about that. But we can add the terms of an infinite geometric sequence if the common ratio, the absolute value of the common ratio is less than 1. So let's go back to our original, this one. We can see here that the common ratio is a half whose absolute value is less than 1. So we can actually add. It turns out, this is kind of cool, you'll like this. The formula, we're not going to derive it. You can derive it if you want to, I'm not. The sum of the infinite number of terms is equal to u of 1 over 1 minus r. So for this example, this is equal to 1 divided by 1 minus a half, which is 1 divided by a half, which equals 2. It's kind of interesting. We can add an infinity, or the idea that 2 is an infinity. 1 is an infinity. I mean, 1 is 1/2 plus a fourth plus an eighth. That's kind of interesting. Let's just go with this. Let's have some fun with this. How about 3 plus a third plus a ninth plus 1 over 27 to infinity? Can we add the infinity? What do you think? Is it possible? Say yes. Yes, u of 1 equals 3, and the common ratio, I'm sorry, I apologize, stick a plus 1 in there. Stick a plus 1 in there. That means the common ratio is 1/3, whose absolute value is less than 1. So we're in good shape. We're going to converge to a number. Think about that for a second. We're going to add an infinity, and we're going to get a number. Well, the formula says that the sum is 3 divided by 1 minus 1/3, which is 3 divided by 2/3, which is 9 over 2, or 4.5. It's kind of interesting. What's even more interesting is that this part, it's 4.5. It's kind of cool. I think that's interesting. Something more advanced, just by looking at this, if this is 4.5 and this is 4, that means this part is a half. A third plus a ninth plus a 27th to infinity equals a half, outside the scope of this class. How about this one? How about 500? This is oscillating. Minus 50 plus 5 minus a half. No, I'll keep it in decimals. Minus 0.5 plus 0.05 minus ... Can we add this up? Well, it's kind of converging. Well, the question is it geometric? Yeah, it's geometric. We know the first term is 1. It's 500. What is the common ratio? Well, it's getting divided by 1/10, but the sign switches, so the common ratio is negative 1/10. And what's good is that the absolute value of that is less than 1, so we can add this infinity up. Let's see. So we have S of infinity is equal to 500 divided by 1 minus negative 1/10. Which equals 500 divided by 11/10, which is equal to 5,000 divided by 11. Kind of cool. Okay. Let's go back to 7th grade because you like 7th grade so much. Some kids write in 7th grade, I hate this so much, but they do it anyway. They write this. I don't like that. What is that? Well, that's 7 repeating. So you go, okay, 7, 7, 7, 7, 7. But actually, and what do we know? It goes on, it's infinite. It goes forever. Well, you know what? Can we write this as a sequence, a series? And the answer is, yeah. We can write this as 0.7 plus 0.07 plus 0.007 plus 0.0007 to infinity. Well, what do I have here? I have this is a geometric sequence. The first term is 1, and the common ratio, first term is 7. I apologize. The first term is 0.7. I'm going to write it as a fraction. And the common ratio is 1/10. right? So that's why I can use the formula. This technically, so the repeated decimal is technically an infinite sequence, a series, and I can use the formula 7 over 10 divided by 1 minus 1 over 10, which is 7 over 10 divided by 9 over 10, which is 7 over 9. And that's so, and you might have learned that little trick. Can everyone take out their calculators or go on the computer and do 23 divided by 99? And you see that it's, 0.23, 23, 23 ad infinitum, which you guys write as 23 with a line over it. I'm not a big fan of that. Now, you could do that with anything, right? You could say, 143 divided by 999. That's also 0.143, 143, so on and so forth. But I want you to explore this. What is 0.9 repeating? It's 0.99999. You can say, okay, it's 0.9 plus 0.09 plus 0.009. You say, okay, Mr. Adler, fine. The first term is 9 over 10. The common ratio is 1 over 10. The formula says 9 over 10 divided by 1 minus 1/10. 9 over 10 divided by 9 over 10, and that equals 1. And that's why 0.9 repeating equals 1.